with an example from environmental engineering. It has been asked in GATE exam also, and probably there are chances it may be repeated in future exams. Okay, so an industry discharges 2 million liters per day. 2 million liters is 2 into 10 raised to 6 liters per day of wastewater with a temperature of 45 degrees centigrade and a pH of 2. So it is highly acidic. We can see pH value is 2. Whereas the neighboring industry produces 3 MLD, 3 million liters per day of wastewater with a temperature of 30 degrees centigrade and a pH of 8. If both the wastewater are mixed and carried through a pipeline, then the resultant pH of mixed wastewater is. Okay, so basically we are mixing two wastewater, and both the wastewater have different physical characteristics. One is having a pH value of 2, another is having pH value of 8. The temperature is also different. The first one is having temperature of 45 degree, another sample is having temperature 30 degree. Okay, so we are mixing both the wastewater, and finally we are supposed to find the resultant pH of mixed wastewater. Now they have given neglect buffering capacity of the system, okay, and the temperature effect on pH. Okay, so temperature will not come into picture. Okay, so what will be the solution? Let me write the data first. See, sample 1, that is Q1, that discharge is 2 mld. Okay, and the respective pH value for Q1 is 2. So what does it mean? It means pH value means hydrogen power H plus, that is equal to 10 raised to minus 2 m. Okay, so this is basically flow 1. I am talking about flow 1. This is our first category. Okay, second, suppose for second case we will have Q2 is equal to 3 mld and the respective pH, let me write pH 1. Okay, so we can differentiate, and pH 2 is 8. So in this case our H plus, here also I am writing H plus 1. Okay, and here H plus 2. So we can differentiate, is equal to 10 raised to minus 8 m. Now we have to mix it. So here basically, see, we have to apply one concept of weighted average. Okay, if we are applying that concept of weighted average, we can easily find out. So we all know the concept of weighted average. So whenever weighted average means we have to basically take the average, but we have to see the weightage also, how much quantity of discharge, first discharge, and how much quantity of second discharge. Okay, so mix on a volume basis. Now see, total volume or total flow rate QT. So it will be basically how much? 2 plus 3 mld. So 2 plus 3 mld is equal to 5 mld. So basically total mixture will be 5. So let's take the weighted average. So H plus of mix, we have the value of individual H plus. So Q1 H1 plus Q2 H2 divided by Q1 plus Q2, or Q1 plus Q2, that is QT basically. Okay, so it is 2 into 10 raised to minus 2 plus, this is for first quantity, plus Q2 is 3 multiplied by 10 raised to minus 8 divided by QT is 5. So basically here we will get the answer 4 into 10 raised to minus 3 m. So pH mix, so we have to just write down the formula. 4 into 10 raised to minus 3. So just by calculator, use your calculator and find out this value. So minus log 4 into 10 raised to minus 3 to the base 10. Okay, we have the h plus of the mix, so the answer is 2.40. So the mix pH is 2.40. I hope you have to apply the concept of weighted average. Okay. Next sum we will see, that is related to pH of a solution containing 0.1 m of acetic acid and 0.05 m of sodium acetate is dash. The pKa value of ionization of acetic acid is 4.76. Solution. Okay. Now see the pKa value they have given, that is 4.76. So basically what is this pKa value? It is the negative base. Basically it is the negative base minus 10 logarithm of the acid dissociation constant, and this is Ka. Basically we are representing it by Ka. Okay, now you have to remember one thing, that higher the value, basically stronger is the acid. Okay, so the formula for an acid base buffer the formula or equation that is known as, Henderson-Hasselbalch equation. So it states that pH is equal to pKa plus log A log, it is not total, it is basically log A divided by HA. Okay, so here always remember the numerator will be, we will be taking as base, and this is your acid. Okay, so concentration of acid will be in denominator, and concentration of base will be in your numerator. Okay, so pK value it is given, it is 4.76 plus log, now obviously it is log to the base 10. Here also I am writing log to the base 10. So log to the base 10. Now here the base, what is base? Acetic acid is not base. Okay, sodium acetate, that is 0.05, that is base, and acid is our acetic acid, so its concentration is 0.1 m. So here also use your calculator and find out the value. So the resultant pH will come as 4.459, equivalent to, we can write 4.46. Okay, but always remember, here I am writing note, always remember, the smaller the value, of pKa. Okay, I think in earlier I made mistake, it is not larger, it is actually smaller the value of pKa, the stronger is the acid. Okay, basically it is in our number line like this. Okay, so the last limit here we are having 10 raised to minus 14. Okay, like that, somewhere around here the values are going this side. If we are going, it is acid, and here they are weak acid. Basically here we are seeing where the lower the values, if we are on this side, left side, so it means the values are low, smaller the values, and it means stronger is the acid. As we move on towards the right side, so the values will be increasing. Okay, values will be increasing, and it will be a weaker acid. Basically this is weaker acid. Okay, thank you very much. So next question is related to sound. A relatively calm room has a background sound pressure level SPL of 30 decibel. So background noise always there is in room. So that is 30 decibel. A TV of 80 decibel and radio 70 decibel start operating simultaneously in the room. So everything we are having three sounds. One is the background sound of 30 decibel, TV is also running of 80 decibel, and radio 70 decibel. Taking the reference sound power, P0 is equal to 10 raised to minus 12 watts. So this if it is not given in exam, you have to remember. Okay, so this is just reference, you should know 10 raised to minus 12 watts. This is a basic, from this reference we will be calculating. Okay, and assuming the three sources act independently. Okay, so all the three sources are there, that is confirmed, and they are acting independently. They are not related to each other. Okay, so what is the resulting SPL in the room? So basically let's make one table so that we can analyze. So we are having source. How many source we are having? We are having basically first source is background. So background noise, some noise will be there. Second is your TV, and third is radio is also going on simultaneously. Okay, so we are having three values, and all the values are in decibel. So one is 30, TV is given as 80 decibel, radio is 70 decibel. Okay, so now let's find the ratio, that is P by P0. So that is P by P0. Let me rub this. This you just remember. Okay, P0 is 10 raised to minus 12 watts. Okay, I am rubbing so that I can create this space. Okay. Okay, so it is equal to 10 raised to L by 10. Okay, so here 10 raised to, what is L? L is your basically SPL. Okay, so 10 raised to 30 by 10 is 10 raised to 3. Here 10 raised to 80 by 10 is equal to 10 raised to 8. Here the value is 10 raised to 70 by 10. So the value is 10 raised to 7. So we are having the ratio. Now total power ratio. Total power ratio, that is our P total by P0. So here the ratio of P total to P0, that is if we are summing up, so 10 raised to 3 plus 10 raised to 8 plus 10 raised to 7, so just sum it up, so you will get the value of 1.10001 into 10 raised to 8. So this is the value of P total by P0. Okay, so why we are interested in this? Because we know the formula L total, because we have to sum up the, see, we cannot directly sum up 30 decibel plus 80 decibel plus 70 decibel. we cannot directly sum up. Okay, all the sounds are acting independently. So and they are, as they are acting independently, we have one formula: L total is equal to 10 log P total by P0 to, and this is to the base 10. So it is 10 log to the base 10 of 1.10001 into 10 raised to 8. So the answer will come around 80.4 decibel. So you can see the sum total is nearer to the highest decibel. Okay, see, whenever here I am adding 30 plus 80 plus 70 decibel, all this I am adding, but the answer I am getting is 80.4. Okay, so always remember that just to get some idea what will be the answer, so it will be always greater than the highest value, and it will be nearest to the highest value. Okay, one noise is of 30 decibel, another is of 80, another is of 70. So ultimately when all these sounds are acting independently, so your answer will be nearer to the highest sound. It cannot be less than 80, obviously. So in MCQ also we can eliminate some options. Okay, so and another thing you remember, just it is not asked in question, but I am telling you, uh, you can note down. Suppose they are asking, I will solve one question afterwards, but just I am giving you the formula. Suppose they are asking about average sound pressure. Okay, SPL. See, summing up of sound pressure level is different, and here the average sound pressure level, that is 20 log to the base 10 1 by n sigma I is equal to 1 to n 10 raised to ln by 20. So this is a formula for average. Okay, and another one important concept, that is equivalent noise level. Okay, see, many times they are asking some questions like 10 decibel noise is there, it is for 1 hour, 20 decibel it is for 2 hours, 80 decibel noise that is for 5 hours, like this, and we have to find out the equivalent noise. So such type of questions are generally asked. So in such cases we have to apply the formula of L equivalent is equal to 10 log 10 log to the base 10 I is equal to 1 to n 10 raised to Li by 10 multiply by Ti. Okay, so what is this Ti? Ti is basically proportion, Ti by total. Okay, so capital T is your total time. Okay, so here suppose if I am considering this case, the total time will be 8 hours. Okay, so and the respective time will be 1 by 8, 2 by 8, like that. Okay, so this is total time. So this just you can remember this formula. Many times they are asking in GATE exam and engineering service exam also. So remember this. If time permits, I will cover some questions related to this topic also. Okay, so thank you very much.